Welcome back, Generals, to another Let's Fix Generals 0 hour to make the best game ever. Yeah, last session we did attempt to fix the terrain modification issues. I still don't know yet which route we go here. Before we go back to this, let's see if there's some actionable code reviews to look at. The problem is we don't get that amount down. It just keeps getting more and more and more and more reviews. I can't keep up. It's too much. It's too much reviews. The problem, I can't focus. It's just too much. Author. So what do we have here? Fixes a network issue that manifested as a result of the asset transfer logic. When a player exits a game, the disconnect frame is not assigned to the outgoing disconnection message. Depending on the timing, this causes user-facing discrepancies in the retake game. Sometimes the game will notify player X has left the game, remove the player. Other times the player will just silently start counting down. The former case, but seemingly more correct, is symptomatic of an unassigned disconnect frame and the received disconnection message from the exiting player, and is what leads to the player not being properly removed from the game. This change now ensures the disconnect frame is always correctly assigned to outgoing disconnection messages and ensures consistent behavior across all disconnection pathways. The assert crash in that is also avoided as a result. The immediate notification of players exiting via the disconnection screen can be looked into separately. It doesn't compile. Okay. Why does it not compile? What is this? VC package error. Let's re-trigger these guys. Rerun failed jobs. So I guess that net disconnect command message. So there will be other messages that set this frame, I guess. Let's see. Disconnect message. Quit game. Quit game. So this is the one that he touched. Yeah, it sets the disconnect frame here. Here's another one. Okay. Okay, cool. Very good. Okay. UI audio no longer plays at maximum volume for a single frame when navigating between the shell map. Yeah, this is a nice bug. This change fixed an issue. We're currently playing UI audio can be heard at maximum volume for a single frame. Issue is caused by a script being run via the shell map. The script reduces sound volume to 5% when opening the options or entering other menu screens in order to silence the explosions. As this also reduces the UI sound effect volume, another script is run to offset the reduced volume by adjusting a manually defined list of UI sound effect volumes to 600%. Oof. When the game processes a volume override command for a particular sound, the override is also immediately applied to any currently playing instances of that sound. However, when the game processes a global volume command, that volume adjustment is not applied until the next frame. Let me take a look at the code before reading on. Sound volume, desired volume. The game processes a volume override command. Stream volume. Currently playing UI audio can be heard at maximum volume for a single frame. The issue is caused by a script being run in a shell. The script reduces the sound volume to 5% when opening the options or entering other menu screens in order to silence the explosions and other noise coming from the shell. Okay, fair enough. As this also reduces the UI sound effect volume, another script is run to offset the reduced volume by adjusting a manually defined list of UI sound effect volumes to 600%. Why 600%? When the game processes a volume override command for a particular sound, the override is also immediately applied to any currently playing instances of that sound. However, when the game processes a global volume command, that volume adjustment is not applied until the next frame. The issue is that it just applies the override without multiplying the global volume. So the sound immediately plays at 600% volume. Just playing volume. Okay. Okay, stream volume. Okay, stream volume. Stream volume, music volume, music. Sound volume. I don't understand this yet here, because there was no... Where is this here? There's 3 audio types, right? There's music volume, speech volume, and sound volume. But here it's only... Let me see that value. Music volume. Yeah, so there's music, speech, sound, and even another one, sound 3D. So there are 4. Sound 3D, sound volume. Sound 3D. Ah, because they are separate, I see. Streams. Okay, so sounds takes care of this. Okay, I see. Playing streams, let me... playing streams, let's see what kind of audios are being pushed in there. You're looking for a pushback. Pushback. Where is it? Here. Sound type music and streaming. Music and streaming. Music streaming. This is technically correct. I suggest to write this as defaults. Debug, crash, unexpected audio type. Speech volume. Actually, the way he has it is more correct because it's in line with this one. Well, still have this here, but I think the way he has it is fine. Yeah. It looks plausible to me, and if that fixes this menu issue, then great. Okay, I guess this is all in core, yeah. Get effective volume. Just playing volume. That would be my other suggestion, that maybe we use this function instead. So we pass in the volume and times this, so that we don't do it manually here. There. Volume times volume shift. Yeah. This all looks correct. Can we do a follow-up change and simplify all these volumes by using get effective volume, then desired volume, then CPP this, becomes CPP effective volume. So it becomes get effective volume. Yeah. Do not show veterancy effects for dead units. Not many, if any, of those concerns apply here. This method is clearly separate into two blocks, logic and then animation. Placing a return between the two blocks is reasonable. Matching the code within both precompiler directives aids in understanding that it is the same logic with only the placement being the difference. So if you insist on keeping the return, then I suggest move the animation code into a separate function with early return. Show frequency level animation or create that animation. let's say effects. Veterancy level effects. Preserve unit behavior when transferring assets to allies. What is this? This change preserves unit behavior when a player's assets are transferred to an ally player. Transferred assets run through the on-capture logic, which tells them to idle in order to prevent undesired circumstances, like the captured enemy objects continuing counterproductive tasks against the capturing player. Don't want a dragon tank to keep flaming our base. Cease hacking. Surrender. Is surrender. The job is done. It's so lazy. Oof, that animation flicker. Oh boy. Unit stop movement. Attack orders when transferred to an ally. Yeah. Hackers continue hacking when transferred to an ally. That makes sense. Units continue movement and attack orders when transferred to an ally. Okay, cool. If old owner on capture. If old owner get relationship, new owner get default team is not allies. Old owner get relationship. Everybody chills when they captured, so they don't keep doing something the new player might not want him to be doing. Chills. Think chills. Okay. Please set comment documenting the new behavior. The new intended. Well, it should be, this should be updated here, this comment. So if old owner relationship default team is not allies, then stops. Comment needs updating. Except when the new owner is an ally. Okay. Good. That's enough reviewing for now. Already 40 minutes of reviewing. Okay, let's get back to our code here. So, world height map. Down here. So the question is, how do we approach this now? So what triggers me here is that we need to update so many of these tiles around our tile. Why so many? Low, y here, +1, x +1, -1, low. X. Do we actually need to update the ambient? Yeah, we do, because we update the normal, so we need to update the light here. Why do we not need to recompute the UV data, by the way? Pre-compute UV, what does it do? Pre-compute UV. Pre-compute UV data. Get alpha, get UV data. Get UV for tile index. Ugh. Yeah. Yeah, this definitely has glitches here. Yeah. It's not very pronounced, but it is there. Let me repeat that here. Those are acrobatics. Good progress. Okay, yeah, there's quite a few tiles here. Oh shit, what happened there? Oops. Also the terrain tracks are out of position there. Well, it's not so bad, but it's clearly visible here, right? There is an issue here. Yeah. Yeah, it's not that bad, but we can see that it's not correct. So we can't do that. think here it's pretty obvious. You see those lines here, right? Yeah. Yeah. Is there any other way we could optimize this? Data mod region. Data mod region. We need to. Yeah, we need to modify this region. Need to modify. I'm still waiting for the glorious idea to somehow combine the two approaches we have here and make one super approach. But it doesn't come to mind. Either we do this bullshit here or this bullshit here. Decision. Take a decision. Oh, it's a dilemma. Dilemma. Need to optimize for speed. What speed? Come on. Some glorious idea here. It must be possible. It must be possible. Maybe. You know, but I realized that essentially we store 4 times the same data, don't we? In Texel normals and also in ambient light. So at every corner position, at every tile corner set point where 4 tiles intersect, like this normal will be stored in each of the tiles and calculated in each of the tiles. So we probably do 4 times as much work as we need to do, don't we? Pre-compute Texel normals. So let me make another visualization of what I think a problem here is. That I think we are doing still too much work. So let's say here we have a tile. Let's make this let's make this nice and large here. Yeah? So we have a tile here, and we have a tile here, and here, and here. Yeah. So 4 tiles. What we do right now, let's take a brush here somewhere. Brush. So we take the normal from here, 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 and here for this one tile. Yeah. And then the next tile will also take these points. Yeah. The same thing. And then the other tile as well will also take these tiles. And then another tile here as well. Right? And as you can see here, we now have 4 times the same normal here, if I'm not mistaken. So maybe what we should do is we should just calculate one normal here in this corner for every tile. So if we calculate it here for this tile, and then this tile up here, and then for this tile up here, and so on, then yeah, we will have all tiles except for the bottom row and for the very right side row. We won't have the outer points. But maybe we don't care because we don't really see it anyway, right? So it probably doesn't matter. Yeah. So what if we were to take, oh boy. So let's say we were to take out this guy, yeah? So we take this. And then we change this to just one normal. UV. Oh, this will be interesting. Okay, and then here light positions. Oh boy. Then here we take this. We say light position. Let's just do that. light position. Alpha 0. Light position, Texel normal, alpha, ambient light color. Okay, then here an ambient light color. Yeah, ambient lights. Color. Let's just do ambient light color. Okay, so basically we now calculate only the top left corner. Yeah, the top left corner of all tiles, which reduces the complexity by a factor of 4. Right? And it also makes the data much smaller. That's also great. Okay, and then we do I think we still need to go in here, do some stuff. No? Do the light, compute ambient light, light rays. Okay, what are we missing now? The do pre-computed lights. Do the pre-computed light. There we go. Right. So here we have diffuse. So what we now do here, tile corner. So we have VB count. And then now instead of doing this shit here, we do so it was from top left, top right, bottom left, right? That was the order before. So I think what we need to do is so we have this one here, VB. Then the first one we do VB array +1. So yeah. So VB diffuse is ambient light, tile corner, color, ambient light. So we take this guy, ambient light X, ambient light color, diffuse. There we go. Okay, and then the next one we do X plus 1. Maybe we can do VB plus 1. There we go. VB plus 1 diffuse. Then we say here top left, top right, bottom right, and then we do another bottom left, so that will be plus 1, plus 1. There we go. Okay, so we array, so it's array, VB array plus 0, 1, 2, 3. Okay, I think that makes sense. So this would be for this, and then for that we would do Texel normal. I mean, same kind of shit, just a bit different. Same but not same, you know? So we would do Texel normal. Here we would do this ambient light. Then we remove this here. Okay, and then we have bottom left. Okay. We also take this here. Okay, and then we take Texel normal, Texel, okay. And then here we do Texel normal, Maybe we should call it Texel normal. How about we call it top left? Texel normal, top left. I think we also need to do the pre-computed light. Yeah. Here we need to, I forgot that, we need to say min x, and then this is m width. doesn't know about width. Mmap get extend, get x extend. -1. Maybe you can just do we can just do const expr cell offset 1. We say say right x const int right x equals and right bottom y is y plus 1, get y extend -1, cell offset. Okay, and then we do right, so this is right x, and this is bottom y. Do the same here, bottom y, bottom right. Okay, and then we take these guys here. And so how about we call this top left, then in world height map we do Texel normal top left. And then here we do base height map top left x, and then we do here VB array. Okay, and then this will be 3, 2, 1. Okay, that would be good. Color, diffuse, blah. Okay, so basically we now sample it from 4 different tiles instead of storing the normals for each corner in every tile. Yeah, we still will have compile errors now in here because we changed something. So this one should be now top left. No, has no member, not top left. Why not? It's here, top left. Texel, normal. Top left. Has no member, top left. I don't understand why this is complaining now. Is this about the name? I don't understand. Okay, let's see what kind of compile errors we get now. Okay, so the hope is that this will reduce our cost by 4. Yeah, which would be quite nice. So what do we have here? Dynamic light. Texel normal. Right. Then this one we need to also update with 0. Texel normal 1, 2, 3, 0. We need the same bullshit there. Let's move this a bit higher up. So X coords. So that would be maybe that and that and that, right? Texel normal. Texel normal. How about we say top left, top right, bottom right, bottom left. Here we say top left. This one is top right. It's bottom right. Bottom right. And this one is bottom left. Bottom left. Good. Okay. Okay, so for some reason it's complaining about all of these guys here. I don't understand why. Probably because of this here. Is this used? Top left. Ugh. Corners, top left. Ugh. num corners for. Yeah. Oh, it's really unfortunate that this shit is colliding here with our... can we... Maybe we do... enum... enum... corner. Bottom left corner. Bottom right corner. Let's call it corner. Bottom left corner. Bottom right corner. Top left corner, top right. Okay. So hopefully that will cause less conflicts now. So we rename this to corner, top left. Corner, bottom left. And bottom right. Bottom right. And corner, top right. Okay, cool. So I hope that this will get rid of this goddamn annoying compiler error that we had. Let's see. No, it's still complaining. Why? Texel normal. Top left. Why is it complaining? Top left. Texel normal has no member top left. Huh? But it's here. Oh boy. Const expr, const int cell offset 1. I think here we can do width. No, we can't. Okay, so it will be top left, top right, bottom left, top left. Okay, for some reason, it still doesn't recognize this word. I don't understand why. We have just added this here. Top left. It says top left. I'm so confused. Why does it not recognize this? Oh, I've misspelled it. That's why. It says lob left. Oh man. My gosh. Oh, the retardation. Then I suspect we also don't need this refactor and road buffer. Yeah, let's reset this one. It's probably no longer necessary. Cell offset. So this position thing here, do we really need the condition for that? Maybe not. Good. Anyway, so now the big question is, will this work? Let's see. Crash. Okay, well, that's a good start. Update sec lighting. Oof. I suspect it's because of our mem setting here. Maybe. Data size. Okay, I'm not sure. I'm not sure why this is crashing now. Did some mistake somewhere. So we have one color, we have one top left normal. No need to recompute UV data. Excel offset minus cell offset. Oh. Okay, I'm not sure why it crashes now. I suspect it's just a memory corruption. Like something has trampled this memory, I assume. Get static diffuse. Access violation. Do the pre-computed light XY. Yeah. Ah, I see the error. Right. We didn't take this into account. There we go. Pre-computed light. How do we do this? I mean, you could add some conditions in here. Yeah. Or we use this use normals code. Do we actually need to preserve that? Maybe that's also something we could have deleted. Let's keep it for now, I guess. Do the light. So cell offset 1. So basically the problem is we're accessing here things when this one is 1, and we shouldn't do that. Yeah. So how do we do this? I think we can do assert debug crash Debug assert crash. Debug assert crash. VB count must be larger than 0 and smaller than 4. The VB count must be no more, must be no less than 1 and no more than VB count 1. Okay, and then we can do if VB count is larger equal to, then we do this. How about we just compute it? Right. Instead of making this function so complicated, how about we make do the pre-computer light VB for 1 fills 4 corners. Fills for top left corner. Maybe we should do that. So this one will be 4. Let me make another variant. VB count. Okay. Then we do normals. Else and if top left Texel normal, that will be VB. There we go. Okay, and then we have this guy. top left, ambient light, XY, VB array, VB, diffuse. Okay, and here we have VB array, cell offset 4. Then we don't need this condition here. There we go. Top right. There we go. I think that's better. Okay. Good. Does that make sense? Yeah. I think so. Good. Let's see if that works this time. We still need to use these guys actually. So this one will be 1. Then we remove the 1 here. This one will be 4. Remove these. That's it. Only 2 callers. Okay, that compiles. Let's see if it runs. Hopefully it does. Hopefully it also works correctly. I don't know. Maybe it will create a new set of problems, but I hope it just works. It looks promising. No, I do see a tile error here in the water. I do see some tile errors here. Oh yeah, there are errors here. Oof. Because of the alpha, right? Maybe. Yeah. So there are errors here everywhere at the edges. I wonder if that's because of the alpha. Some mistake we made. Yeah, but it probably is fixable. Let me see. So basically here alpha not sure. Yeah, I'm surprised by this. So it doesn't blend on one of the sides, only on the other. Yeah. Oh, I suspect that some problem with the alpha value. Maybe we can only have maybe for the color, maybe only the Texel normals can have this optimization, but not the color. Yeah. It's possible, yeah. So maybe the Texel normals, we can't do this. For Texel normals, we can do it, but for color, here we cannot have this kind of optimization. Which would still be a safe. Yeah. Color. Yeah, so let's put it back on to 4. Ugh. Texel normal. Ugh. So maybe we need the same bullshit here. Const expr, const cell offset, one x y width height x y y x and oh shit. We remove this. Then we keep this. Make the slide positions 4, 0. Ambient light, tile corner. Tile index, ambient light. Tile corner. const color equals that column not const color shit r dot r g b a. So Texel normal. Oh boy. Let's do Texel normal for 0 1 2 3 Texel normal I can't type. Tile corner, top left, light position, light positions, tile corner. Oh boy. Const vector 3 normal top left position const vector 3 pos normal pos pos was up here before. Light positions. Top left. Let's do here Texel normal plus tile corner. Alpha tile index. Yeah, so this one then goes back to tile corner. Okay, and then let's go back to base height map. Then here, do pre-computed light. color, ambient light. Yeah. Okay, let's put this guy back here. Yeah. Let's also put this guy back. Where are we? Here. Now I need to carefully copy this shit out here to recover what it was before. Ugh. Okay. Roundabout, like so. Okay. Bum, 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 bum. Then let's comment out this shit down here. Okay, so now we only did the changes to the Texel normal, not to the other guy. But this won't work here, Texel normals. No, this here is not correct. Let's do and if let's comment this out for now. It's incorrect. Failed. Oh, right. Okay, so this should work now. But I still wonder if we can do something about the light. Yeah. Okay, yeah, this looks normal now. Okay, so this is great. Effectively, we reduce the Texel normal calculation by a factor of 4. Cut its cost by 75%. Okay, that's fantastic. But maybe we can cut more. Let me put a breakpoint at... breakpoint at... Uh, okay, let's see if terrain modification still looks fine. I think this looks very good. Yeah. Okay, cool. Yeah, so visually this is all good. But I do wonder, let's take a look at the lights. Let's put a breakpoint in world height map. Put a breakpoint at anywhere. So let's take a look at ambient lights. Let's take a look at ambient lights. Y times m width plus x. So let's take some value, I don't know, 200, or let's say 100. So 100, 100, yeah. And then we take a neighbor of this plus, so so these guys are next to each other, right? So this is top left, this is top right, and this is top left. This is bottom. Hold on, don't get confused here. So this is top right, and this is top left, and they are not the same. Okay. This is bottom right. No, this is bottom left. This is bottom right. These guys look very similar. Top left. This one is top left and this is top right. They are identical. Okay, they are identical. Look at that. So this one is identical to this one, at least as far as we can see. So it's this one and this one and this one and this one. This is the wrong color. This one and this one. Yeah, they are the same. Maybe there's an opportunity here, and we just did it implemented wrong. That could be. We just implemented it wrong. Oh. Let's think about this. I suspected this possible, but maybe we made a mistake somewhere. Let's take a look at it again. So color. Texel normal. Pre-compute ambient light. So get ARGB. Yeah. Cell offset. So it seems that there is some error with the alpha value. I have a suspicion. Yeah. The suspicion I have is the problem is with this one here. So if we only take this value, yeah. Value data cache. UV. I think what we can do here, other than touching this guy here, what we can probably do take these guys here. And we do tile index. Get pre-computed alpha UV data. Let's do a const alpha UV data get alpha UV data xy const return alpha UV data cache plus y times m width plus x. Okay, and then get pre-computed alpha UV data alpha UV data pre-compute ambient light. Now we don't know which corner to take. Yeah, it's a bit of a dilemma here. We don't know which corner we're at. No, I think it's fine. Pre-computed alpha data, so we give it, oh boy, x. So this is alpha UV data top left. XY. Okay, then we do top right. Bottom right, bottom left. So that would be right X, right X, bottom Y, bottom Y. Okay. And then we take alpha top left, So we take top left, alpha 0. Then we do alpha max, alpha 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 so it will be top right, and top right we have to take top left, top. No, we have to take, hold on. We are top left, so we're looking at, let's look at, we need to use actually left X and top Y. So it's X minus cell. Max. Data. Data top left. Data, how do we call this? Left X, top Y, top Y. How do we call these guys? Let's do this for UV data, and then left. Top left, top. I do a top left, top left, top. And then that will be, so left we need to go to the right side, so that will be 1. On the top left we need to go to the bottom right, so that will be 2, and that top, 1 to the top, so that will be 3 here. Yeah. Okay, so if I'm not mistaken, that will give us some max alpha values between these guys here. Okay, maybe this will work, which then begs the question, why do we need multiple of these here. Maybe we can also consolidate these in another step. Maybe. Good. So yeah, so the hope is that we now get the correct alpha. We just take the max alpha of all the corners of the surrounding tiles, and that hopefully gives us a correct result. Oh boy, what is this? Oof. Oof. Okay, so let's see. And crash. Oh, fantastic. Access violation. Okay. Why is that? Oh. Well, yeah. 0, 0. Okay, that looks promising. Okay, that's pretty cool. Okay, that means we effectively reduced our Texel normals and our ambient light information by the factor of 4. That's amazing. Makes it... Oh, I do see some error here though. Oh. Oof, okay, not so great. Ah. It looks close though. Just some errors over here. That sucks. Did I make some mistake here maybe? Let me think that through one more time. So we have X, Y. Left X, yeah. Top, left. Left top and top. Cell Y minus cell offset, yeah. This seems fine. And then alpha. So alpha is 0, max, left. So that's right side. If I'm not mistaken. Top right, bottom right, left. So this is right side. Right, and this is top left. So this is bottom right, yeah. This is bottom left. I would have expected that this is correct. It looks almost correct. Which still makes me believe I have an error there somewhere. But it's just not obvious, because it looks almost correct. Like most of the edges look perfectly fine here, right? Like most of the beach here looks perfectly fine. So it seems there is something wrong here with the way I do it. But what is it? Alpha UV top. Probably put this here. So left side. That's correct. Top Y. Yeah. Top left. Pre-computed alpha UV. Yeah. Alpha. Alpha 0, 1, 2, 3. Alpha top 3. Bottom right side on the top here. What is wrong here? I don't see it. Maybe it's not supposed to work like that. Yeah, there certainly are errors here. Hmm. Mm-hmm. Hmm. Oh boy. I don't know what the problem is here. Maybe it's not supposed to work like this. Hmm. Hmm. Yeah. Hmm. Hmm. Alpha 0, 1, 2, 3. Left. It looks correct here, right? So this one is properly blended. It looks correct in most places. But then there's some odd places where it doesn't look right, like this one. Yeah. Yeah. Maybe we can't do it. Maybe we can't do it. Hmm. This alpha value here is the only thing that stops us from optimizing the ambient lights for the... Yeah. Yeah, I don't know how this... why this doesn't work. I would have thought it would work. Yeah. Alpha 0, 0, 0. Conditions. Alpha is not 0. 255. 0. 255 on 2 edges, 2 corners. There as well. Top left and top left. Ooh. So there's a Okay, I would like to see something. So alpha UV data cache. Let's put that into our watch. So our current XY is 249. Alpha UV data cache 100 times M width plus 100. Okay, let's change that to 249, 103, 249, and 103. Then we go 102, and then we also do we do 184, 103. Okay, I hope my order here is not all that confusing. But so basically here we have alpha. Hard to say. Yeah, this is it's hard to follow this. I don't know. I don't know if overlapping positions like these on the grid would have the same value. So if one point here would have 244, 255, then all the other points would as well. Maybe that's not the case. Ugh, I don't know. Yeah. I don't know. It seems to not work, so it's unfortunate. Yeah. Yeah. Hmm. Yeah. The alpha at this position, it's can we see how is this computed, this alpha UV data? Here, get alpha UV data, alpha. Okay, it fails to jump at the right function. Get UV for tile index. UV. Get UV for tile. UV tile index. Okay, what about the alpha? Alpha is here. Okay, it initializes it all to 0. 255. Blended tiles. Three-way blend. Three-way blend. I really don't know. probably is some way to optimize this, but I can't wrap my head around this right now. Yeah, it's I don't know enough about this alpha value to really derive the right conclusion. It could be that it's I mean the fact that it looks proper in most cases, but it doesn't look correct in some cases, it implies that there are some... Oh no, I pressed something that froze the rendering here. I don't know what that is. Some debug command. Ugh. Yeah, I don't know what it is. But clearly it works for most of the tiles and some not. So I assume that there's some special cases where my assumptions of alphas on all corners being exactly the same is not true. But each tile is its own thing, so to say. Right? That's my only explanation for this. Otherwise, this should work correctly. Yeah. It's only here a few tiles. Like all this here, all this looks correct, right? This stuff here. All these edges. This one looks incorrect. Here we have some incorrect ones, and here. But otherwise, we have a lot of correct blended tiles. And then some are broken. Yeah. So it looks like we cannot make some assumptions here. Okay, I will revert this part of the change again. I tried. Didn't work. Good, then we put back in the color 4. And we remove all this again. We put in this, so we have light positions. Yeah, makes it more expensive here. Light positions 0. Then we remove this. 4. 0. Say right X, bottom Y, plus width minus cell offset min m height minus cell offset positions tile corner Texel normal tile corner alpha alpha is this here position color okay Can also remove this again because I was not used anymore. Okay, and then we go to base height map. And then here we do this. Do that. And then we do this one, and then these two, and then we put in these back, and that means we now need to implement this one here. How do we do that? If def use normals, and if I think similar to what we did here. Similar to this guy. Cell offset. Texel normal. And then Texel normal. Tile corner. Top left. Save def1. If1. World height map. Get X extend. Get Y extend. Map. What is the problem here? There's no member NZ. Oh, this doesn't even work. Well, that's stupid. It doesn't even work. Okay, and otherwise we just do that. Okay, cool. Then yeah, this should work. It's a bit unfortunate because this one is still pretty costly over here. Doing all this shit, yeah. But okay. It is what it is. Good, so let's see if that compiles. Okay, let's see if that also works. Const. Okay. 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 Looking foods. Prevent Chinox from taking off while they're still units wanting to enter or exit. Okay, cool. Good. Let's check the game. Let's load the level skirmish. Let's look around. So the tiling looks all good, except for this one, but this was already there before. Okay, cool. Then let's clean up this optimization. So we will remove this. Top left sample, remove that. And that's VN UN. VN UN, quick height, max. Get quick height. X. Texel normals. Shouldn't this be also maxed here? Hmm. Hmm. This one doesn't look safe here. Because XY. Yeah. This one probably should be min. Okay, how about we do V? How about we do min width minus cell offset Well, here we do 0, and then we put this to the other side. Then here we make plus, plus, m height. Oh, it's the other way around. M height. Let's do x first. X. So we call this left x. And this we call top y. And this one we call left right x and bottom y. This is right X, bottom Y. Okay. And then that should do. Good. So we take this guy. We take all this. We take this and this and this. We take this and this. This. What about this here? Const per const. Put this up here. Okay, I take this guy, take these guys. Okay, we take all this here. Take that. Good. We reset this. And then we reset. I think that's it. So top left. Left X, top Y, right X. Okay, then let's test it one more time that this actually works correctly. We can probably also simplify this here a bit. We can put these vectors here. We can remove this. Then we can put this like so. I think we can also let me double check how things look here when we shoot. Let me go with a night map. This one is good. Okay. Yeah, this looks good to me. Okay, cool. It's very good. Very nice. Interesting that this was broken in the original game. It looks really nice. Cool. Okay, I think that looks perfectly fine. Then we will do here optimize Texel. Actually, hold on, there was one more thing. This one is plural, but it's actually just one. Let me do Texel normal. Maybe we should rename this to compute ambient lights. Didn't save. I think I was a bit too ambitious here with the rename. Okay, let's take this guy. And these guys. Then we also take this. Optimize Texel normals to compute just one corner instead of 4. Okay, then next. Next, I would like to make a fix-up commit for this guy here. Create a fix-up where we take we compute ambient lights. Let's make this plural. S. And then we stage this guy, and we stage these guys, and also this. First is done. Good. Let's clean up the other shit. This here. This. And all this here. Okay. Good. So now we have this guy here. I think we can commit this. Do we want to do this here? It has static lights. Let's just do let's do this, and let's iterate that out first, comma, it's done. Not is done. Let's do that. Then we can revert this change here. Okay. Okay, now the last consideration is the goddamn terrain modification. So we have made this one cheaper, Texel normal, yeah. That one, that one is now cheaper. But the ambient light is still expensive. Yeah. Okay, what approach do we use now? Oh, we are back at square one here. Man, I really want to do this here because it's in place No complex, no complication, but yeah, it's so much here. If it was just +1, -1, max, I think we can write this here a bit better. 0. I don't know. Do we take this or not? After terrain, after tile height was modified, must update tile and surrounding tiles. 25 tiles in total. Expensive. After that, must recompute. Let's say it's not cheap. Yeah. And there still is a dilemma now. Ah, no, with this one, there's no dilemma. No, this one will only touch the things that we, in fact, touch, but it does it in not particularly efficient way. Yeah. Is there anything else we can optimize here? If we could somehow know in advance that the region that we want to touch, like if we could pass like multiple indices. Pre-compute, Texel, normal. This could be cheaper by post-processing the affected region in the next update, but it would require the state to maintain. It would require an additional state to maintain and complexity. It's probably still cheaper than the original, because the original, so let's say we touch a region of, let's get the calculator. Let's take, so the original draw area is 129 by 129. So this is the minimum amount of terrain tiles it needs to modify in the original game when it modified the terrain anywhere. And then it would go through 16,000 tiles and recompute them, right? Now with this optimization, it's still not optimal as I've described here, but it's significantly lower than that. And so let's say we touch, I don't know, let's say we modify 100 terrain tiles, which sounds like a lot in one go. Then this times 25, so we 2,500 tile modifications, which is still lower than the 16,000. Now, if we touched all at once, like the whole viewable area gets touched, and that times 25, then that would be much more expensive with 400,000. But that's not typically not what happens. Typically, we raise, you know, just a few local tiles here and there. So on average, it should be much cheaper still. Yeah. The most efficient would be if you would really just recompute all the things once instead of multiple times. Yeah. It would be interesting to test this in World Builder. But my expectation is if we compile World Builder now, it will fail to compile. We have some terrain here, some slopey terrain. Let's get to Alpine Assault again. It's great for testing. My favorite spot here. This is home. Yeah, this looks good. Visually, it's all good. I still have some reservations about the performance there, but I mean, it should be faster than the original game, so we should be in the green. Yeah. Yeah. Okay, cool. So how about we make another performance capture now? Let's go to... Oh, where is it? Diagnostics, record CPU. Let's do it on... Yeah, let's do it here. That looks pretty fast now, doesn't it? Because... Actually, I don't know why. I don't know. Because we still have it shelved, I see. That's why. Yeah. Then let's merge this guy. Yeah. I would say we move this function here to the CPP. Let's put it here at the bottom. So I take this guy and then like that. Modify height value. Let's put this information here at the end. Then we remove this here. Okay, also remove this. Remove that. That. Okay. Oh, this one still needs to be removed. Okay. Then we say here, properly recompute Texel normals and ambient light. Texel normal and ambient light around modified tiles. Compute normals and ambient lights around modified terrain tiles. Okay, then we do a stash pop. And then we do compile. And then let's test how much stalling we still have left. I think there still is something in regards to the fog, or what is it called? The shroud. The shroud, there's still some cost. And I think that would be it then. So let's go to DEFCON. DEFCON. Okay, let's see. Okay, there's just a small store left. Good, let's make a performance capture of that. Okay. So CPU, flame graph, and how do I search here? Well, we can already see it here. So update center, init height data. Yeah, so memset 32 is still left. We don't care. So the update stuff is now much cheaper here. Update block. Display height. Yeah, so this looks pretty good. And so now the biggest position is this here. Good. Good. How about we take a look at this refresh shrouds? Set shroud level. Oh, there's DirectX call, draw pixel. Set shroud level. Okay, there's a loop. Total cell count. Draw pixel. Oof. Oof. Yeah, how do we optimize that shit? Disable shroud, I guess. Play without shroud. Radar. Oh, it's on the radar. Why is it refreshing the radar? Huh. Okay, that seems weird. When we... I understand that we need to refresh shroud for the 3D world, but for the radar, it shouldn't make a difference, right? The radar should just stay the same. Oh. 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 So on every... Oh, I see the cost is... On every time a shroud thing is edited, it goes through all the points on the radar and modifies it. What? What is this? Yeah? Is legal radar point X, Y. Drop pixel. So it refreshes, so... Yeah, so what happens is we go through all cells and update the shroud level, which is fair. But then within each of these updates, we also go through the whole radar and update the radar every time again on every cell. So let me put a breakpoint on there. Oh shit, what is this? This thing. Let's put a breakpoint here. So, oh, that's not much. Okay, actually, it's not a big deal here. That loop. Okay. It's just 2 points. Okay. Illegal radar point. Draw a pixel. But this is expensive. Draws a pixel. Pixel size. Ugh. What? Oh. Okay, it is interesting that this is this most expensive part of this shit. It's weird that the recording we just did disappeared now. Why is it disappeared? I didn't tell it to disappear. It's okay, but we remember it was the draw pixel that was this expensive. So it seems that this draw rect is very expensive. Yeah. Let me do another recording. Set shroud level. So git description is expensive, whatever that is. Direct X codes, yeah. Mm-hmm. Yeah. Get description. Log rect. Unlock rect. Yeah, I guess drawing one pixel is not so great. I guess that each time it does that, it needs to communicate with the GPU, with the VRAM, and that's probably expensive for every single pixel. Yeah. Log rect. Yeah. So I suspect what we need to do is don't draw a single pixel, but combine the pixels all in one surface and then commit it all in one go. That's my suspicion. Okay, I will take a break here. It has been 4 hours. Next session we can continue investigation. I have a rough idea of what we can try doing. We need to avoid calling this for each and every single pixel. Try to make one call for it and then probably will be fast. But yeah, I don't know yet how to do it. Maybe I can ask ChatGPT to help a bit with this. Give some ideas. Yeah. Good. I will take a break here. I wish you a great day or night. Until next time. Goodbye.